Your table is 80% dead rows. And it is getting bigger, not smaller. Every update creates a new copy. 500 megabytes on disk. Only 100 megabytes of live data. The rest is dead tuples. 5 times bigger than it needs to be. A query that should take 3 seconds takes 47. How does this happen? Every update in PostgreSQL creates a new row version. The old version stays until vacuum marks the space for reuse. But vacuum does not shrink the file. To actually reclaim disk space, you need PG_repack. This table grew 400 megabytes in a week without a single insert. Stay, I show you why, and how to fix it in production without downtime. Why does bloat happen? PostgreSQL MVCC. Multi-version concurrency control. Every update is an insert new plus mark old dead. Step 1, original row, transaction ID 100, row version 1. Step 2, update changes the email. PostgreSQL inserts a new row with transaction ID 101. The old row is marked dead but stays in the page. Step 3, another update. A third row version. Now 2 dead tuples. The page fills with dead rows. New inserts go to new pages. The table grows. Vacuum marks dead space for reuse by future inserts. But it does not remove the empty pages. Vacuum full rewrites the table but takes an access exclusive lock, blocks everything. PG_repack rewrites without locking. The key insight, vacuum prevents growth but does not reverse it. How to detect bloat. 3 queries. First, PG_stat_user_tables. Select n_dead_tup, n_live_tup, calculate dead percentage, and check last _autovacuum. Sort by dead tuples descending. This gives you the quick overview. Second, statuple. This is the precision tool. It scans every page and gives you exact dead_tuple_%, free_%, and table_len. The cost, it reads the entire table. Run on small tables or during low traffic. Third, PG_relation_size versus PG_total_relation_size. The first is the table only. The second includes indexes and toast. If relation size is 3 times the actual data, you have bloat. Quick interpretation. Dead percent over 20, needs attention. Over 50, critical. Last _autovacuum null, autovacuum never ran, check if it is disabled. 3 tools. Different trade-offs. Vacuum. No lock on reads or writes. Marks dead space for reuse. Does not shrink the file. Fast. Run it frequently. Autovacuum does this automatically. Vacuum full. Rewrites the entire table. Returns space to the OS. But takes an access exclusive lock. Blocks all reads and writes. On a 500 megabyte table, this can take minutes. Use only during maintenance windows. PG_repack. Best of both worlds. Rewrites the table without locking. Creates a new copy, applies changes via triggers, then swaps. Needs free disk space equal to the table size. Install the extension first, create extension PG_repack. Vacuum analyzes the daily driver. Run after bulk operations. Updates statistics for the planner. Vacuum freeze prevents transaction ID wraparound, the silent emergency that can freeze your entire database. Autovacuum tuning. The defaults are conservative. The formula, threshold plus scale_factor times number of rows. Default threshold is 50. Scale factor is 0.220%. So on a 10 million row table, autovacuum triggers after 2 million dead rows. That is too many. For hot tables, set autovacuum underscore vacuum underscore scale underscore factor to 0.01. Set autovacuum underscore vacuum underscore threshold to 1000. Now it triggers after 101,000 dead rows. Per table override, alter table orders, set storage parameters. Global tuning, autovacuum underscore max underscore workers 3 to 5. Autovacuum underscore vacuum underscore cost underscore limit 400 to 800. Autovacuum underscore vacuum underscore cost underscore delay 2 milliseconds. These let autovacuum run faster. The nap time is the sleep between database scans. Default 1 minute. Decrease to 10 or 20 seconds for busy databases. Monitor with PG underscore stat underscore user underscore tables, last underscore autovacuum underscore count, n underscore dead underscore tup. Index bloat. The silent killer. Vacuum cleans table bloat. But it does not clean index bloat. B-tree indexes grow when rows are inserted and deleted. Deleted index entries leave empty leaf pages. The index gets bigger but the useful data stays the same. How to detect state index. It gives you leaf underscore fragmentation, average underscore leaf underscore density, and empty underscore pages. If leaf density is below 60%, the index is bloated. How to fix re-index concurrently. Available since PG12. Builds a new index alongside the old one. No read lock. Also PG underscore repack with the -I flag to repack a specific index. Plain re-index without concurrently locks writes avoid in production. Live demo part 1. Detect and vacuum. Left terminal, detection. Check table size, 500 megabytes. Check dead tuples, 1,051,000 dead out of 3 million total. 35% dead. Then statuple for exact numbers, 34.82% dead, 3.12% free. Right terminal, run vacuum verbose. Removed 1,051,000 dead row versions. 64,000 pages, 0 removed, all remain. Check size after vacuum, still 500 megabytes. Vacuum does not shrink the file. Dead tuples are gone, n underscore dead underscore tup is 0. But the space is only marked for reuse, not returned to the OS. To actually shrink, PG underscore repack. Next slide. Demo part 2. PG underscore repack. Run it, PG underscore repack -d prod -t orders. Repacking table public.orders. Check size, 105 megabytes. 79% smaller. Verify with statuple, dead %0, free %1.23. Clean. While we are at it, re-index concurrently on the primary key. Done. The sidebar tells the story. Before, 500 megabytes, 35% dead. After, 105 megabytes, 79% smaller. Query time, 0.03 milliseconds. And 0 downtime. Reads and writes continued during the entire repack. PG underscore repack creates a new copy, applies changes via triggers, then swaps atomically. 5 bloat mistakes that fill your disk. 1. Long-running transactions. Open transactions hold back vacuum visibility. Dead tuples cannot be removed while any transaction might still see them. Set idle underscore in underscore transaction underscore session underscore timeout to 5 minutes. 2. Disabled auto vacuum on hot tables. Altered table set auto vacuum underscore enabled false seems harmless. It is a ticking bomb. Dead tuples accumulate silently. 3. Default auto vacuum on 10 million plus row tables. 20% scale factor means 2 million dead rows before vacuum triggers. Set scale underscore factor to 0.01 per table. 4. Bulk update without vacuum after. Updating 1 million rows creates 1 million dead tuples instantly. Run manual vacuum analyze after bulk operations. 5. Ignoring index bloat. Vacuum cleans table bloat but not index bloat. B-tree indexes grow silently. Use state index to check, re-index concurrently to fix. 5 tools covered. Vacuum for dead tuple cleanup. PG_repack for zero downtime compaction. Xtatuple for precise bloat measurement. Autovacuum tuning for prevention. Re-index concurrently for index bloat. Detect cheat sheet, PG_stat_user_tables for dead tuples, Xtatuple for exact bloat, PG_relation_size for table size. Fix cheat sheet, vacuum analyze after bulk ops, PG_repack for compaction, re-index concurrently for indexes. Tune, autovacuum_vacuum_scale_factors 0.01 on hot tables, idle_n_transaction_session_timeout 5 minutes. From 5 times bloated to clean, compact, monitored. If you manage PostgreSQL in production, subscribe and press the bell icon. Like if this helped. Save for reference. Next up, cheat sheet number 3, PostgreSQL replication commands. Streaming replication, logical replication, failover, and PG_stat_replication. Dr. Ibrar Ahmed. PostgreSQL Deep Dives. See you in the next one.